everyone. Welcome to E&E Learning Hub, where I'm going to go through and explain the solutions for question 4 from the 2021 Csec Electrical and Electronic Past paper. So let's begin. Part A of 4. It says, list 3 reasons for conducting each of the following tests and checks on a complete installation. Part 1 of A, visual inspection. So the 3 reasons are: 1, to make sure that the installation complies with safety standards. 2, to ensure that the installation comply with electrical codes and regulations. 3, to ensure that conductors are connected properly. Alright, so that's it for part 1 of A. For part 2 of A, the 3 reasons for doing continuity tests are: 1, to identify short circuits. 2, to determine if conductors are broken. And 3, to determine if the switches are working properly. Alright, so that's it for part 2 of A. So let's move on to part B now. Part 1 of B, it says outline the procedure for conducting a polarity test on a complete electrical installation that is not connected to an electrical supply system. Alright, so here's the procedure. 1, main switches and fuses are out. 2, the lamps and other apparatus are disconnected and the switches are on. 3, one lead of the polarity tester is connected to the phase at the outgoing side of the fuse, and the other lead touches the terminals of the switches. If the polarity is correct, the reading will be less than 1 ohm normally. If the wrong conductor is connected to the switches, the polarity tester will give a high resistance reading. Alright, so that's the procedure for testing the polarity for the switches. Now, for the socket outlet. For the socket outlet, one lead of the polarity tester is connected to the phase at the outgoing side of the fuse, and the other lead touches the live terminals of the socket outlet. If the polarity is correct, the reading will be less than 1 ohm normally. If the wrong conductor is connected to the terminals of the socket outlets, the polarity tester will give a high resistance reading. Alright, so that's it for part 1 of B. So let's move on to part 2 now. It says outline one procedure for conducting a polarity test on a complete electrical installation that is connected to an electrical supply system. Alright, so here's the procedure. One lead of the portable test lamp is connected to the known air conductor at the main switch, and the other lead is used to touch the incoming terminals of the switches. The test lamp should light up. Alright, so that's it for the procedure, and that's it for part 2 of B. Now let's move on to part C. It says, with the aid of label diagrams, show the relationships between the phase and line voltages, phase and line currents in each of the following. For part 1, 3-phase, 3-wire, delta connected secondary winding of a power transformer. For part 2, 3-phase, 3-wire, star connected secondary winding of a power transformer. Alright, so we're going to start with part 1 of C. So here's the diagram of the 3-wire delta connected secondary winding of a power transformer. Now, the relationship as it relates to the phase current with the line current and the phase voltage with line voltage. So for delta, the line voltage is equal to phase voltage, and the line current is equal to the phase current multiplied by root 3. Alright, so that's it for part 1 of C. For part 2 of C now, so here's the diagram. So this is the star connected secondary winding of a power transformer, and for this connection, the line current is equal to the phase current, and the line voltage is equal to the phase voltage multiplied by root 3. Alright, so that's it for part 2 of C, and that's it for this question.